If Earth had a magnet strong enough to erase every hard drive on the planet, it still wouldn't hold a candle to what I'm about to tell you. There are stars out there whose magnetic fields are so extreme, they can tear atoms into spaghetti. They're called magnetars, nature's most ridiculous magnets. A magnetar is a kind of neutron star, the leftover core of a massive star that went supernova. Imagine the sun, crushed down into a city-sized sphere about 20 kilometers wide. Now give it a magnetic field 1,000 trillion times stronger than a fridge magnet. That's 1015 Gauss. For comparison, an MRI is about 3 Tesla. A magnetar can hit 10 or 11 Tesla. At those strengths, the rules get weird. Electrons spiral so fiercely they quantize into tight tracks. Atoms stretch into needle-thin shapes. Empty space itself starts behaving like a prism. Light can split and change speed depending on polarization. Vacuum birefringence predicted by quantum electrodynamics and only recently hinted at in observations. Magnetars don't just sit there. Their crust, an ultra-dense lattice of nuclei, locks up tension until it snaps. Starquakes. When that happens, magnetic field lines twist and reconnect, releasing bursts of gamma rays and X-rays that can outshine the entire Milky Way for a split second. In 2004, SGR 1806-20 let loose a giant flare so bright it rattled Earth's ionosphere from 50,000 light-years away and saturated multiple satellites. If one went off within 10 light-years, it could strip our atmosphere. Luckily, none are that close. So where do these monsters come from? The best idea is a newborn neutron star, spinning hundreds of times per second. That rotation, plus convection in the ultra-hot interior, acts like a dynamo, winding up a colossal magnetic field before the star slows down. And it slows fast. Magnetic braking bleeds rotational energy, powering bright X-ray glows and occasional outbursts for 10,000 years or so. Magnetars also glitch. Their spin rate suddenly jumps, like a cracked ice skater pulling in their arms. Possibly because superfluid components inside rearrange, and they might be connected to one of astronomy's big mysteries, fast radio bursts. In 2020, SGR 1935-2154 fired a radio blast so intense it finally linked at least some FRBs to magnetar flares. What would a magnetar do to you up close? At 1,000 kilometers, it could distort your molecules. Your credit cards? Wiped from a third of the distance to the moon. Get much nearer, and you're a charged particle painting spirals in a death coil. But they're also laboratories, natural particle accelerators and stress tests for the laws of physics we can't replicate on Earth. To me, magnetars are a reminder that the universe isn't just big, it's intense, tiny, dense, and absurdly powerful. They flip our intuition on its head and show us where physics bends but doesn't quite break. And somewhere, right now, one is holding its breath, waiting for the next starquake. When it snaps, the galaxy will hear it.